Compressor blades are key components in a jet's engine. Thousands of them whirl inside the engine, rotating 400 times per second and whipping air into small hurricanes. Large compressor blades made of titanium compress the air in front of an engine's turbo chamber. In the back of the chamber, smaller blades made of nickel alloy compress it even more. The air heats up to more than 1,000 degrees, then combines with jet fuel, creating a powerful mix that explodes out the back of the engine. The blades start off as metal pellets called slugs. A ceramic layer prevents their surfaces from oxidizing when exposed to intense heat. The slugs are heated for 15 minutes in an 1,800-degree oven. Meanwhile, a robot sprays lubricant on 2 dies inside a press. The robot retrieves the slugs and loads them in the first die. The press applies over 1,000 tons of pressure to preform the metal. The robot then transfers the slugs to the second die, where they take the initial shape of the blade. The blades are dipped in water to cool. Another robot cleans the metal burrs off the edges. The blade is now an airfoil. Robots will shape the rounded base of the blade, called the dovetail, later. The airfoil has gone from this to this. After a new ceramic layer is applied, the blade is heated again. Each heating and cooling cycle tempers the metal, making it more resilient. Almost 1,800 tons of pressure gives the airfoil its final shape. A trimmer shaves off the excess metal. The searing heat has turned the protective ceramic layer into glass. That will come off later. It's taken an hour to shape the blade's airfoil. The dovetail, that nub on the right, is next. But first, this measuring machine inspects the airfoil. If any measurement is off by just half the thickness of a human hair, the blade doesn't make the cut. This casting machine will encase the airfoil in a matrix, a coating that protects the airfoil during work on the dovetail. The matrix is molded from liquid tin and bismuth. It solidifies into a metal cast around the airfoil. The future dovetail sticks out at the end. The cast is then loaded into what is called a broach machine. Its series of teeth carve the dovetail into its final shape. Now the cast can come off. A worker loads it onto the removal machine, and a hydraulic cylinder hits the cast at its weakest point, breaking it in half. The finished airfoil emerges unscathed. A dot matrix machine punches identification numbers onto the blade. Next, the blades are submerged in a fluid that penetrates any flaws in the metal. This inspection is critical, because even the tiniest nick can spell disaster when a jet's engines are working at full speed. Inspectors examine the blades under a black light. This one's perfect, but spots of fluorescence on this one indicate microscopic cracks and weaknesses. This one gets rejected. The dovetail gets 2 strips of rubber silicone that ensure an airtight seal when the dovetail slides into the slot on the compressor drum. A final check, and the blades are now ready for takeoff.